Hello all, I am Kshitij Agarwal with Apurv. We are from group 15 and this is our phase 0 of the project for ENBM 700. So let's start with the component overview first of all. Visual Initial Odometry, or VO for short. It is a technique used to accurately estimate a robot's position and orientation by fusing data from the camera, which is the visual aspect, and the IMU. And by combining the information from the camera and an IMU, VO achieves more accurate and robust motion tracking, compensating for the limitations of each sensor individually. For instance, there is always drift in the IMU and visual ambiguity in low light conditions or poorly lit environments from cameras. Now it will combine the camera and the IMU data to estimate motion by fusing visual features tracking with high frequency initial measurements. The IMU data needs to be pre-integrated because of the slower camera frames, since IMU's throughput is much faster than any camera. And then non-linear optimization methods, LM for instance, are used to fuse the data and provide much accurate positional information. Moving over to the activity diagram, as you can see, for better understanding of the pipeline. On the left, we see the overall view architecture with two branches for visual and IMU odometry respectively. Now looking at the image registration process, which is on the leftmost side, we pinpoint and highlight identifiable descriptors from the input image given by the camera. These key points are then matched with the previous frames, which aids in calculating the spatial location of all those points. Next up is the pre-integration process. The raw input from the IMU is corrected to account for gravitational force and integrated to get the location or position and instantaneous velocity. And this output is then integrated with IMU bias components and finally returns the corrected position and velocity. Now for the visual odometry on the right hand side, that is the final overarching pipeline. After matching the key points from subsequent frames, we will estimate the tentative motion using the 8-point algorithm and finally update the visual odometry. Once we have both of these information from the respective sensors, we can always go back to the optimizers and try to minimize the cost function and give us the most optimal state or the output, which is the position in our case. Thank you.